Say, hello, everybody. Thank you for being here. I'm super excited to introduce Chris Price to talk about how to metabolize cellular architectures. Cellular architectures are quite common and they are promoted heavily, but there's very, very little information about how they're built and how to actually think about cellular architectures. It is awesome to have somebody who has built multiple production services with cellular architecture come in and present their perspective on the what, the how, and the why of cellular architecture. And so I'm super excited for this talk, and I'll pass it on to Chris to start dropping some wisdom here. It is a two-part series, and we're scheduling the second part to be set up in a couple of weeks. And good to see you, Michael. And if you want to register a request for an APAC friendly time, you can relay that directly to Chris as he's the speaker.
All right, thanks, Kawaja. Yeah, so before I get started, I'll say this talk definitely focuses a little bit more on the how. And we're definitely going to get into the what and the why of cellular architecture a little bit, but the talk itself focuses a little bit more on the how based on lessons I've learned from trying to manage cellular architecture at a few different previous jobs. And one of the reasons why I wanted to split it up into two is digging into the how. There's quite a lot of content that we can get into, and I wanted to make sure to leave a little space at the end of the time today to do some Q&A or just have discussions if people want to dig into anything a little bit more, including the what and the why if I don't cover that as much in my talk. So this will be probably a little on the shorter side as far as talks go, and then we should have plenty of time hopefully at the end if anyone wants to ask questions or talk about different ideas for cellular architecture. And then we'll have another session in a couple of weeks, like Kawaja said, to follow up on a few things that I won't hit today. All right, so just a little bit about me really quickly. The last few jobs that I've had, I worked at Puppet for about 5 years, kind of when I feel like the word DevOps was really becoming a thing for the first time. And that was a really formative experience for me because it really got me thinking about how to manage infrastructure and how to do automation around infrastructure. It was kind of pre-cloud though. And then after that, I moved on to AWS, and that's when I really started getting much deeper into cloud things. At AWS, I worked on a team that built a video streaming service that was used for part of the Amazon Videos Thursday night football broadcasts. And we built the service there as a cellular with a cellular architecture as its foundation from the ground up. So that was a really awesome learning experience for me. And now I work at Momento, where, as many of you know, we produce serverless caching and pub sub products. And one of my early contributions when I joined Momento was to help kind of make sure we had a good solid foundation for cellular architecture for Momento. So that's a little bit of my background as far as it relates to this talk. So yeah, before we get into some of the details about my personal experience with cellular architecture, I'll zoom out a little and just talk about the concept in general. I always want to make sure that I call out that this isn't something that we came up with or invented. There's definitely a lot of other content available out on the internet about this. So there's other great resources if you're interested in learning more. One resource that I liked a lot was in 2018 at reInvent, Peter Vachel gave a talk about AWS and how they minimized a blast radius of failures that happen inside of the different AWS services. And that's kind of among the first times that I'm aware of that people started using this term of cell-based or cellular architecture. And what he talks about in his talk is it really has to do with the different levels of isolation or fault tolerance that the services inside of AWS use to try to minimize the blast radius when a problem occurs and guarantee as much uptime and availability as possible to all their customers. The first two on here, you're almost all certainly familiar with, regions and availability zones. So most of the services in AWS, like Dynamo, S3, and most of the other ones, Lambda, they're regional services. So when you interact with them, you pick a region that you want to work in, and then all of your API calls and all of your interactions with that service happen within that given region. And that gives them their first level of like isolation, fault tolerance. That means that if there's some kind of physical outage that occurs in like US East 1, or any of many other types of problems that are prone to happen in US East 1. But if something goes wrong there and your service is using Dynamo in US West 2, then you're not impacted by that. So then inside of the regions, there are usually at least 3 availability zones, which are basically physical data centers inside of those regions. And that gives you another way to think about structuring your application in a way that gives you more fault tolerance. So you can have some of your resources replicated or distributed across multiple availability zones in a region. And if something goes wrong in one of those availability zones, it doesn't impact your ability to continue to execute your application in the other availability zones. So those are kind of the basic building blocks that they really expose front and center to the customers. But then after that, in Peter's talk, he talks about this idea of cells. And a cell, for the purposes of this conversation, is really just an isolated deployment of your entire application. So it's a self-contained deployment that has all of the different infrastructure resources that are required for your application to end to be able to serve traffic. And what that cell looks like in terms of whether it spans availability zones or an entire region, like those kind of details end up being a little bit more specific to your business use case. And you can design your cells in a lot of different ways. You can design them so that they span a whole region. You can design them so that they only live within inside of a single availability zone. But however you design them, the key point is that you have this like isolated atomic unit that is an instance of your application, and you can direct traffic to it. And then if you have multiple cells, and there's a problem that causes an issue with one of them, it won't impact your traffic and your customers in one of the other cells. This is the same exact concept as what AWS is talking about with regions and availability zones, but it's a unit that you can make decisions about and control yourself in terms of how you want to maximize your availability. So in this diagram that he shows here, he's showing an example of a cellular architecture where there are multiple cells deployed inside of each availability zone, and the red squares are intended to highlight a failure. And what he's really talking about here is that a lot of times when you have an outage in your service or your application, the cause of the outage has something to do with some customer's traffic that's coming into you. So it may be a certain type of request that you just haven't seen before that triggers a bug in your application that you hadn't caught up until that point. Or it may be just like an unexpected burst of traffic that you get from some customer that just overwhelms some limited resource that you have in your application and causes an outage. But in either of those cases, and he calls those either poison pills or black swan events, or those are a couple of terms that he uses to describe those. So when you have one of these kinds of events, however small your cell is, that is the impact. That's the limit of the impact of this outage. And while you recover from that, all of your other cells are unaffected, hopefully. So that's kind of the what and the why. And I'm going to start digging more into how now. But like I said, at the end of this talk, if we have questions to dig into the what and the why a little bit more, we can definitely do that. Okay, so when I've worked on teams where we were building out the foundation for a cellular architecture for our service, these are kind of the main goals that I felt like we need to have a solution for. So the first one is isolation. How do we keep our cells isolated from one another? Second one is, how do we create a new cell when we need to? A third one is monitoring. Once we start to have this proliferation of different cells out there, it becomes a little bit more challenging to monitor them in a holistic way so that we can see the utilization and the health of all of the cells in a single spot. And then deployments, that is probably the most challenging part. How do we manage deployments of new versions of our software to all of these cells as the number of cells increases over time? And then permissions. So for any cell that we have a set of inbound permissions and a set of outbound permissions that it needs to have configured. So inbound permissions control what kind of traffic can come in to various entry points into the cell, and outbound permissions control what resources that the cell can reach on the network and stuff like that. And we have to have a consolidated way to manage those as the number of cells grows, or it gets really tricky to keep everything up and running. So these are kind of the 5 goals. In this particular talk, I'm only going to end up covering the first 3 of these for today, and then just for the sake of time and to make sure that we have a little bit of time for Q&A and stuff at the end of the talk. And then the second series of this talk will cover deployments and permissions, which are a little meatier in some ways. So one thing that I think is really important to highlight when you're thinking about building cellular architecture is that automation becomes really important. As the number of cells grows over time, any places where you don't have automation for any of the key components of managing that cell, it just becomes exponentially more expensive over time, and your engineers end up spending a larger and larger percentage of their time setting up new cells, figuring out how to monitor them. So it becomes really important to think upfront about what parts of this that you can automate in a general way across all of the different cells, so that when you need to spin up new ones or tear down old ones, that most of the work is simple and safe and not risky manual operations that your engineers have to be responsible for. And so to achieve automation across all of these cells, one thing that's important to be thinking about is what kinds of things you can and should standardize about the different components of your application or service in order to make them interchangeable enough that your build tools and your infrastructure can perform certain operations on them in a general way, because of the standardization that allows them to look and feel a little bit similar. And I'll get into more details on that now. So one of the things that we found to be really useful in terms of standardizing the components of our application up front is coming up with some way to standardize build targets. And so what I'm talking about here is whatever components you have in your application that you need to deploy in order to deploy a cell of it, you're almost certainly going to have a bunch of different components there. These days, you're usually going to have at least a handful of microservices. And there may be a lot of differences between how you build your different microservices. There's no hard and fast rule that you need to use the exact same technology stack for each of your microservices. And in many cases, it would be a bad idea to do so, because some technologies will work better for certain types of microservices and other technologies for other types of microservices. But if we can think of ways to standardize some of the life cycle of our different microservices, regardless of their technologies, then it gives us the ability to start automating some of the things around how we manage ourselves. So what I'm showing here is we use a pretty simplistic way to solve this problem. We just have make files, and we have a make file that we put into each of the components of our application that has a standardized set of build targets in it. And that way we know when we're writing any code that needs to automate any parts of our infrastructure, we know that we have this standard set of build targets available across all the different application components. And that allows the infrastructure code to be thinking about it in a more generic way. And so the key one here that I wanted to call out is that both of these make files have this target called cell bootstrap, which is just a target that we use to deploy a new version of this component or this microservice for the very first time into a new cell. And you can see the one on the left, this service has some Gradle commands involved in it, and then it calls some npm commands for infrastructure. This is a Kotlin service that uses some npm stuff to build it. The one on the right is a microservice that is written using Rust. So the commands that you see in there are cargo, and then we've got some scripts that do some of the infrastructure stuff. But as long as we standardize on the names of these build targets, the infrastructure code that's manipulating these things from the outside doesn't actually know or care what technology stack we're using for them. So that's one little bit of standardization that gives us a lot of power going forward. Another one that we use both at my job at AWS and at Momento is coming up with a way to define a registry of your cells. You'll never, you never ahead of time will dream of how many different places this can become useful. How many different parts of your infrastructure and your dev tooling and everything else, where it becomes incredibly useful to have some central registry that has all of the important metadata about what cells you have created and where they live, how to access them. If you have this central registry available and you have a way to access it from all your different tools and infrastructure, it really opens the door for a lot of different types of automation and dev tooling. So here you can see a handful of TypeScript snippets where we've just defined a model for what a cell means to us at Momento. And so one interface here just has some DNS configuration, and then there's this cell interface on the bottom left. This is kind of the main one where we keep track of each individual cell. And we've got some information like a region, the DNS configuration, a scale so that we can have different sizes of cells, and then this cloud provider config. For us, we actually deploy our service to both AWS and GCP. So this cloud provider config gives us a way to indicate whether a given cell is an AWS cell or a GCP cell, and a few other things like that. And then on the right-hand side, we have this interface that we call our org. And the important part of this is one of the fields in it is called cell accounts. And it's just an array of this cell configuration over here. So this is just a very simple model that we created to allow us to keep track of all the important details that we need to know about any of the cells that we're operating. So then using this model, we can basically just build out a data structure that here's that cell accounts array. And in the cell accounts array, we've got a list of cells, and we have all of the little pieces of metadata that we need for each of the cells. So we've got the region, the scale, the account ID, and the DNS information, and so on. So this is just like a simple little data structure that keeps track of all of the metadata based on that model that we created on the previous slide. And what you do with this after you create it is totally up to your own needs and your own use cases. If you have really sophisticated requirements or goals, you could put all of this stuff in a database, and you could have a schema where you're modeling this in a database. For us, most of the cases that our dev tools or our infrastructure code needs access to this cell information are pretty simple. And so all we do with ours is we just stick it up into an object on S3. And then we have a tiny little bit of library code that knows how to find it at any given point in time and pull the data down. And then you can write code that interacts with this data as basically we have these little library functions that know how to find the cell data from the cell registry. And then we can just use these library functions from whatever code we need to. So those things give us some building blocks to start to standardize some things across our services and allow us to start writing general purpose infrastructure code. The last one I want to talk today in terms of standardization is the idea of a cell bootstrap script. So like I mentioned before, your application that you're trying to deploy into a new cell is almost certainly made up of quite a few different components. You probably have several microservices, as I mentioned. You probably also have some infrastructure that's kind of shared infrastructure that's reused across the microservices. So that might be shared networking resources like VPCs or NAT gateways. It might be shared database tables, any kind of like core infrastructure that's reused across other components of your application. And for us, we also have a separate one for DNS records. We like to keep those separate from the rest of our infrastructure because there's a lot more risk involved with making changes to the DNS records. So we like to keep them kind of isolated so they're not touched as frequently. But in any case, all these things probably each have their own Git repo, or if you're a mono repo shop, they probably have their own directory and project somewhere inside of the hierarchy of your mono repo. But because of some things that we can do with standardization, like the idea that I was talking about earlier about creating standardized build targets, it opens a door for you to do something like this, where you can write some really generic infrastructure code that here what my code is doing is it's reaching out to that cell registry to get information about the current cell that we're going to do something to. And then basically you just have this line of code here that clones all of those Git repos or checks out the mono repo and makes sure that everything's set up for each of those projects that we need to have involved in the deployment of our application. And then we can just loop over all of those, and for each one of them, just call that generic make target. So here I'm just calling this cell bootstrap make target. So with this tiny little bit of infrastructure code here, I now have this really generic way to loop over all of the different required components of my application that are necessary for doing something with a cell and running some consistent lifecycle command on them without this code having to know anything about what programming language or other things are relevant to the given components. Okay, so that was a little detour to talk about some things that we could standardize in order to make it easier for us to implement cellular architecture. Now we're coming back to these goals that I mentioned at the beginning of the talk: isolation, new cells, monitoring, deployments, and permissions. And as I mentioned at the beginning, I'm not going to hit those last two today. So for the rest of the time, we're just going to focus on these three. So we'll start off with isolation. The mechanism that I've had the most success with for achieving isolation for a cell is an AWS account. This is a pretty common thing that people do inside of AWS, but it's also worked well for us at Momento outside of AWS. And if you haven't done this before, it can be daunting at first. It seems kind of challenging to have to keep track of an ever increasing number of AWS accounts and all of the credentials and other things that go along with managing those. But the tooling that AWS provides for this today is actually getting pretty sophisticated and pretty powerful. And there are some really compelling reasons to consider this as the mechanism for isolation for an individual cell. The most important and most powerful one in my mind is that you basically get all of the isolation goals that you're trying to achieve between the different cells of your application. You basically get those for free if you put each cell in its own separate AWS account. It is certainly possible to come up with a design for your cellular architecture where you're going to put more than one cell into the same AWS account together. But as soon as you start doing that, the mechanism that you have to use to isolate them from one another is basically managing IAM permissions. And managing IAM permissions, as anybody who's spent any time doing that knows, is probably the most daunting thing to do when you're working with AWS services. It's really hard to get right. It's really easy to make a mistake in your policy and leave something open that you didn't mean to. And it's not always easy to know that you've done that. So if you are able to design your cellular architecture where putting each cell in its own separate AWS account, then they're isolated by default. And the only stuff that you need to do with IAM is about granting permissions rather than revoking permissions. And that is just a much simpler and safer starting point. This screen that I'm showing here is a screenshot from the AWS console from the organizations service, which is provides some pretty great ways to group your accounts together. You can see here that we've got like different folders in our organization. We have got one called Cell, and that's where we put all of our Cell accounts. We have some other different kinds of accounts that live in different folders. And IAM actually does have some pretty good capabilities these days for granting permissions based on this organizational structure, and that makes a lot of things simpler as well. So yeah, number one reason to consider doing it this way is it really simplifies your life when it comes to IAM permissions. Another really awesome thing that you get for free if you do it this way is the billing data. When you set up your AWS organization, you can set up one account to be the main billing account, and then all of your other accounts get linked into it, and the billing information gets rolled up there. And then when you go to like the Cost Explorer screen, you can group by the linked account and get a really easy like view into which of your cells are costing the most money and where you should be looking for optimizations and such. This is another thing that you can do on your own. If you put multiple cells into the same AWS account together, you can be very deliberate about how you apply like tags to the resources that you're creating in those in the account. And then you can come in here and group by tags and get the same kind of holistic billing information. But again, it puts all the onus on you to figure out how to do that. Whereas if you use separate AWS accounts, it does a lot of the work for you just out of the box. Okay, so another thing that we have to think about with in terms of isolation for our cells is routing. So how does traffic get to your cell? And this question ends up being something that's really case by case. For Momento, since all of our customers are interacting with our cells through our SDKs, we don't have to surface the DNS names directly to the customers. We can kind of bake that logic into the SDKs and the auth tokens that we give them. And that allows us to basically just create a unique DNS endpoint for every single new cell that we create. And then we can manage through the SDK which customers get routed to which cells. That works great if you can do it. It's probably the simplest architecture in terms of the number of moving pieces that you have to deal with on the server side. But it doesn't work for everyone. If you have a web app where customers are typing in the DNS name directly, you'll notice in these DNS names up here that I have both the AWS region as part of the name, but I also have like the cell ID as part of the name. And that can get really unwieldy. If you have to expose that directly to your customers, that can be a really difficult thing for them to have to deal with, and can be a bad user experience. So if you have a web app that you're hosting or some kind of service that you're maintaining where it's important for the customers to be able to come in through a single DNS name, then you're going to probably want to do something like this, where you have a routing layer added to your server-side architecture. And the routing layer, what this looks like is going to be a pretty business-specific thing. But the goal is to keep it as thin as humanly possible. So it doesn't do anything except for take whatever the incoming request is, figure out what cell it needs to get routed to, and then route it to that cell and then get out of the way. You have to, since this is like becomes a new sort of single point of failure in your architecture and a new piece of infrastructure that you have to maintain, there are tons of motivations to keep it as thin and as simple as possible. So like the simplest example that I can imagine is that if you had, say, an HTTP service and a request comes in here, maybe your customer's customer ID is represented as a query string, a query parameter in the URL or something like that. And this routing layer might just read that query parameter and then have a database table that it has cached to where it knows which customers get routed to which cells, and then route them accordingly and do nothing else but get out of the way after that. This approach, in addition to in addition to it being an extra thing that you have to manage on the server, it has another sort of hidden implication, which is that now you have to worry about your routing layer being able to scale in the same way that you have to worry about how your cells scale. So one thing that can be really powerful about having a cellular architecture is if there's something in your cell that is resource constrained, like a database that can only scale to a certain amount of traffic, then being able to create new cells may give you a way to scale that resource without having to figure out a sophisticated solution to whatever the bottleneck was there. And so you may be able to scale your application horizontally by creating new cells as you need them in route and just redistributing your traffic between them. But the routing layer is sort of this global resource in this picture here. And so if it has any scaling constraints, you can't solve them by adding new cells. So it's just another thing to keep in mind when you're figuring out your scaling story. And then this screen I was going to show real quick. This is a screen from the AWS SSO console, which I think they have now renamed IAM Identity Center. This just gives your developers a nice way to get access to the different cells. So this is a tool that they provide that makes it easier to manage a growing number of AWS accounts. You can set it up to use like your Google identity provider to let your developers get access to this screen, and then you can control what kinds of roles they have for the different cell accounts and so on. So it's kind of an entry point into looking at the AWS console in different accounts, and it makes it easier for developers to do the tasks that they need to do in the different accounts. So that thing has been getting pretty powerful these days as well. Okay, so isolation, we talked about solving that with AWS accounts, organizations, cellular endpoints, choosing between direct cellular endpoints for each cell or a routing layer. So now we'll talk about new cells. This one goes really quickly based on the standardized building blocks that I talked about earlier in this talk. So to create a new cell with this model, all we really need to do is create a new AWS account in the organization. And then we add it to our cell registry. And then we just run the cell bootstrap script that I showed a minute ago. And for a quick refresher, these are the building blocks for that. We basically have the cell registry that has the information about this new cell account we've created. So we can grab that, and then we just clone the Git repos for all of the different components, and we loop over them and run this make target. And that brings us from 0 to a fully operational cell just with that little chunk of code. So yeah, I said that one was going to be quick. That was really all there is to it based on the standardization we did earlier. And then the last one we're going to get into today is monitoring. This one's also going to be pretty quick. There's not a lot of magic to talk about with monitoring here for cells. The number one thing that is probably pretty obvious is you have to make sure that your cell name or your cell ID is a dimension on all of the metrics that you emit, so that you can tell metrics from one cell apart from metrics from another cell. You need a way to centralize your metrics across multiple accounts. If you're primarily using like CloudWatch for all of your metrics, they do have a way that you can aggregate CloudWatch metrics across from multiple accounts down into a centralized account. And that will work pretty well as long as you've got dimensions on there for which accounts they're coming from or which cells they're coming from. For us, CloudWatch is a little unwieldy, a little expensive, so we're not actually using that. But there's tons of other metrics things that you can choose that have this one minimal required capability of being able to group metrics by this cell dimension. So there's New Relic, Datadog. The one that we're using is called Lightstep. This is a screenshot from one of our dashboards on Lightstep. Nothing super interesting here, but you can see that I've highlighted one particular time series in this graph. And if I look at the tooltip that it pops up, I can tell exactly which cell this data is coming from. And Lightstep has kind of grayed out a bunch of these other series in the background because I'm focused in on this one. But each one of those would have a similar attribute on it where I could tell which cell the data was coming from. And so that's really all there is to say about monitoring. Just make sure you have a dimension for your cells. and that you have some centralized metric store that knows how to do group aggregation on or group by on that dimension. Then a few things that are nice additional benefits besides the blast radius stuff that we talked about if you build out your architecture this way. One is agility, like the ability to run that little bootstrap script that I showed and crank out a new cell in a really short period of time is incredibly powerful, especially if you're a small business that needs to be able to react quickly to requests coming in from your customers. Like if you need to be in a new region quickly to support some new use case that a potential customer has. Being able to do that in a matter of hours is a huge enabler. When I was at AWS, my team didn't actually have quite this level of automation for our service. And so when we needed to roll out a new cell for a new customer in a new region or whatever, we just had this giant spreadsheet that had like 200 rows of sort of like checklist items that an operator needed to walk through manually. And so when it was time to build out a new cell, some poor sucker on our engineering team would get handed that spreadsheet and we'd be like, okay, we'll see you in a couple weeks. And they just have to like tediously crank their way through it. Inevitably, something would go wrong on step 15 that would require you to go back and undo the previous 3 steps and then redo them and then update the spreadsheet with a little note for the next person to try to prevent them from hitting it. So having a bootstrap script like the one that we have here, it does require a little bit of maintenance to make sure that it stays in sync as your application's changing, but still overall the amount of work for getting a new cell up is so much lower, and the business value that can provide can be huge. It also makes it really easy to spin up single tenant cells. If you have a really big new customer coming online that you want to keep completely isolated from your public cells that you have multiple other customers in, it's really easy to do that. And then the last thing that I think is really valuable and sometimes gets overlooked is it makes it really easy to create a developer shell. So a lot of places that I've worked will have some kind of, there are certain kinds of dev tasks that you need to do when you're building a sophisticated service where you can't really test them on your laptop. If it involves the interaction of a couple of different components in your architecture, it's really hard to set up the whole environment on your laptop. So you end up needing some place you can do it that's more like a real world environment. And a lot of places I've seen will try to solve that by having some kind of shared development environment where a bunch of developers can get into the same place and have a real working version of the system that they're testing their changes on. But whenever that happens, you inevitably get into the situation where 2 developers start working on it at the same time. One of them accidentally breaks something the other one's working on, and the other one breaks something that the other one's working on. Neither one of them know that's happening, so they both end up wasting like several hours trying to figure out why their stuff isn't working before they realize that they're stepping on somebody else's toes. And that can just cause like a ton of wasted effort and be a kind of a morale killer. But with this model, it's really easy to have each developer have their own AWS account that they can just do the same bootstrap thing and spin up the whole environment. You usually would probably want to do it with scaled down version of like your instance types or whatever, so that it's not costing as much as a real production cell would. But it makes it a lot easier to get one of those up and running quickly, give a developer an isolated place to test their own changes, and then tear it back down to save costs again when they don't need it anymore. So those are some like really powerful side benefits that come out of this, in addition to the main goals of reducing blast radius and making sure your customers have the best availability possible. And that's kind of where I wanted to stop for today. Next time we talk, we can get more into the details about how we handle the deployments out to the different cells, which is really kind of the most complex part of all of this. But hopefully this kind of sets the stage for that. And I'll stop there. And if anyone has any questions or ideas you want to chat about, we can use the rest of the time for that. Checking the chat here to see if any questions came in there. Michael asks, for reproducibility, because you're mix and matching so many components, each of which can be versioned, how do you keep track of the overall version of the system? That is an awesome question, and that is a really hard problem to solve. The answer at most of the places that I've seen this before is that you kind of don't. the there's a foundational assumption here that all of the components of your service are going to have a kind of a continuous deployment model, meaning that every time a change is made to one of the components of your service, as soon as the commit goes in, it's going to start working its way through this continuous deployment pipeline, and then all the cells are going to get that update one at a time. And it's kind of on the developer, on the engineering team, to design all of the changes that you're rolling out so that they're always backward compatible with whatever existed before. And that way, as the changes roll out, even though different cells or different components in a cell may have slightly different versions at different points in time, as long as everything's always backward compatible, everything should interop safely, and eventually everything will catch up and get the latest changes. Now, that's like a very oversimplified and naive way to describe it, in that the real world, there's often things that come up that are a lot trickier than that. There's cases where it just may not be possible to roll out a new change in a completely backward compatible way, or more likely, much more common, you can have these scenarios where you have changes in two different microservices, where the change in microservice 2 depends on the change in microservice 1. And so it's really important in a scenario like that you have a story that allows you to make sure that microservice number 1 rolls out, the deployment rolls out all the way through to all of your cells before you start rolling out the deployment for microservice number 2. And that gets, that gets into this situation where it's kind of up to how much engineering time you want to put into your attempts to automate stuff like that. Most of the engineering teams I've seen, those types of changes are rare enough that what you end up doing is just like making sure everyone on the team is aware when you're in one of those rare situations. And then you kind of block the deployment for one of the services until everybody has kind of been helping keep an eye and make sure that the deployment completed for the dependent service. And then after you got the all clear there, you kind of unblock the deployment for the other one and let everything catch up. And hopefully that's rare enough where that level of sort of manual oversight that you have to put into it is not a huge burden for your engineering team, and probably costs you a lot less in terms of engineering dollars than whatever solution you might come up with to try to fully automate that. So that's kind of how I've seen that handled in the past. But there may be cases where it is so crucial to make sure you understand the version relationship between every one of these components that you actually do want to invest more engineering time in your deployment strategy to make sure that you have some way of coordinating those versions between different components. When we talk about deployment in the second part of this talk, like some of that'll come to the foreground a little bit more, and we can dive into that a little bit more deeply if folks are interested. But that's kind of bird's eye 10,000 foot view answer to that question. Erica asks, do we always want to use cellular architecture, or are there any scenarios where we should not? I would say definitely, like, the decision of whether it makes sense for you or not is really case by case and really based on your business. I would say the most important axis for the decision is whether or not your application can function properly as a cell. And what I mean by that is that, like, I wish I had like a more concrete example of this to throw out there. If anybody else does, feel free to jump in. But you may have some kind of global database table that has global data that is relevant to every single user of your service. And trying to carve that data set up into cells that were isolated from each other might make the application like not be able to fulfill its purpose anymore. If like user number 1 really needs to be able to see all the data that has been generated by all of the other users in the system, And you can't really carve it up into cells where some customers are over here and some are over here, because then the data is sharded out in the same way and everyone doesn't have access to the whole set. So those kinds of problems where you have some kind of global resource that is important to the operation of your application for all of the users, that's when it gets kind of hard to do cellular architecture. But if you have a model where like the data that an individual user cares about is mostly only their data and they don't care about the other customers' data, that is when it becomes a lot easier to define these cellular boundaries where you're splitting the application up and giving users their own isolated spaces. Even in that situation where you do have global data, there are ways that you can use replication and still be able to design a cell that works for it. But that's kind of the most basic example I can think of a case where it's hard. And it looks like Mira might have something better to add to that.
Sorry, I was trying to find my unmute button. So I think it's always a trade-off. Like if you start going with too much cellular architecture, you start having to deal with all those accounts and then, different alarms and alerts firing for all of those. So for example, our canaries, they are not cellularized in the sense like all of them run in one account, but it's a different level of cellular architecture where they are more regional in nature than like being cellular in nature. So it's always trade-offs. Like at some point, it's not worth to really go cellular. And with cellular also, you can go all the way down to like AZs being cellular. Like you can have each AZ deploy an instance of your application and then go cellular that ways. So it's how much overhead are you ready to deal with to provide that isolation?
Yep, I agree with that. I would say though, like some of it, if you don't think about it up front, it can be really hard to make it cellular later. So it's nice to at least make sure you put in enough thought up front so that you know how you would do it and then kind of have some basic building blocks in place. And then maybe you make deliberate sparing choices about not overusing it and not creating more cells than you need to. But if you do a little bit of planning up front so that you know what a cell would look like, it makes it way easier to react later, rather than try to retrofit your app to something that would work with it when you didn't start with that in mind. Cool. Any other questions or topics that people are interested in getting into? All right, well, if not, I really appreciate everybody joining today. Hope that was at least a little bit informative. And Kwaja, maybe you got something to say to add?
Oh, thank you so much for presenting this. Oh, Michael had asked a question, right? Oh, that's actually a really good question. I'll shut up.
Yeah, I don't know. Did I mute myself? No. Okay. Michael asks, you talked about account isolation. What other methods of isolation do you recommend? So I mean, really, isolation comes down to making sure that the permissions that you set on the resources for your application will protect one cell from another cell, and will make sure that traffic gets routed to the correct cell. So really it comes down to, if you're not going to do it at the account level, then it comes down to just making sure you have a good story for how you're going to manage your IAM policies, so that, like, let's say you have two cells of your application that you're deploying into the same AWS account, and they both have, say, like an Aurora database or something involved, and you have two separate databases, one for each cell. But you want to really make sure that your IAM permissions are set up so that a bug that happens in one cell can't somehow end up making writes to the data in the other cell. So it really becomes a matter of figuring out how to set up the IAM policies properly for all of the resources that exist in your cell, to restrict them so that they cannot interfere with one another. And so, that the thing that makes that challenging is, IAM is hard in and of itself, but it also becomes really dependent on what types of resources you're using in your application. The way that you set up the best IAM permissions for any different type of resource in AWS, it really varies a lot from one service to the next. So you kind of have to make sure you understand all of the permissions that are available for each of the AWS services that you're consuming, and that you choose the right ways of configuring those policies to restrict oneself from interfering with the other. And then the routing part is the other important thing, is like, how do you make sure that the traffic that is coming in from one source stays within the appropriate cell that it was targeted at. And so there's probably some network permissions involved with that to make sure that traffic is always being contained in the right, like, VPC for the individual cell. But really, yeah, I mean, my short answer for that is, if we're talking about AWS, it really boils down to the two options are using accounts or using IAM permissions, I think. It gets a little different with some of the other cloud providers, and I didn't really dig into that today, but yeah. Hope that answers your question. If not, feel free to ask more. All right, cool. Well, thanks again, everybody, for joining. And if you're interested, we'll have the follow-up in a couple weeks here. We'll get the announcement for that out soon, and in that one we'll dig in more to the deployment story, like how we actually roll out the software changes to all the different cells. But yeah, I really appreciate everybody's time. Hope you have an awesome Thursday and great weekend.
Thanks, Chris.
Thank you.